Hi everybody. We're going to find the zeros of this polynomial function using a trick that you first learned in Algebra 2. So let's get started. So what we're trying to do is we want to solve the equation 27x cubed minus 64 equals 0. So we're finding the zeros of this polynomial. Now the key to understanding this is to see, so we can at least be thinking this if you don't have to write it down, that this equation really says 3x quantity cubed minus 4 quantity cubed. So this is the difference of two cubes. And that's a special factoring pattern that you learned in Algebra 2. So we can directly factor this equation. So let's see. We have normally when this formula is written in Algebra 2, it's a cubed minus b cubed. And then this factors into a minus b times a squared plus a times b plus b squared. So we factored it, and now we set each factor equal to 0. So the first factor, well, that's no big deal. We just have 3x equals 4. So one of our zeros is x equals 4/3. To find our other zero, we set, or sorry, our other two zeros, we set the other factor equal to 0. Unfortunately, there's not a common factor, and I don't think this is going to factor, period. So you can either complete the square, which doesn't look like a whole lot of fun, or you can use the quadratic formula, which also doesn't look like a lot of fun, but I guess that's our least worst option. So let's see. X equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Goodness, the numbers here are not wonderful to deal with. So let's see. Negative 12 plus or minus the square root of 144. I don't want to try to do this in my head. It's late in the evening and I might make an arithmetic mistake. So let's see. 4 times 9 is 36. 36 times 16. All right, let's do this the old-fashioned way. So let's see. 6 times 6, that's 36. Carry my 3. 18, 21. Go to 0, 6, 3. So we have 6, 7, 5. 567. Whew, goodness gracious. 5. Did I say 67? Sorry. 576. All over 18. Okay, so 144 minus 576. Let's go ahead and get ready to do that. So I'll say minus 144. 6 minus 4 is 2. 7 minus 4 is 3. 5 minus 1 is 4. I should choose my examples more carefully for YouTube so I don't have to do so much arithmetic. All right, negative 12 plus or minus the square root of, now it's negative 576, so this is negative 432. All over 18. Okay, so we need to simplify this square root. So that means we're going to need to factor 432. Now, a nice factoring trick, if you don't remember it, if the sum of the digits of a number is divisible by 3, the number is divisible by 3. So 4, 5, 6, 7, 8, 9. That's divisible by 3. So 432 is divisible by 3. But the same trick also works for 9. If the sum of the digits is divisible by 9, this number is divisible by 9. So 432 is divisible by 9, and 9 goes into 432. 9 goes into 43 4 times with the remainder of 7. 72, 9 goes into 8 times. So that's 48. And 48 is 16 times 3. So, if you want to simplify this radical somewhat quickly, we have the square root of 9 is 3, and the square root of 16 is 4. So if you can find those perfect squares, that number is actually not that bad to deal with. So we have negative 12 plus or minus. Let's see, we took the square root of 9 and the square root of 16. That's 3 times 4. Well, 3 times 4 is 12. We took the square root of a negative, so it's 12i. And inside the radical, the only thing we were left with was this 3 all over 18. All right, now, all the terms here are divisible by 6. So we can divide by 6, and we have negative 2 plus or minus 2i square root 3 over 3. And thus we found all 3 of our zeros. Remember, we found 4/3 very quickly, and we just did a bunch of arithmetic to find these 2 zeros. Negative 2 plus or minus 2i root 3 all over 3. So long story short, don't forget your sum and difference of cubes formulas from Algebra 2. They can be useful for solving polynomial equations now. See you next time.